I'm Anil Kumar, and in this video we will understand the characteristics of a transformed exponential function. The question here is, write the characteristics of the exponential function f of x equals to 2 to the power of x minus 1. Sketch the function. Now we are given the function f of x equals to 2 to the power of x minus 1. So that means the function 2 to the power of x has been translated 1 unit down. Now when you translate the function 1 unit down, then what happens? Normally x-axis is your horizontal asymptote. If you translate, then minus 1, y equals to minus 1 will become horizontal asymptote. Now since this is always increasing, it will also have an x-intercept. Since now minus 1 is a horizontal asymptote, function is increasing, so it will cross the x-axis. So it will have an x-intercept. It will also have y-intercept. Domain is all real numbers. Range is greater than minus 1, right? So these are few characteristics which we could write. So let us begin by the domain itself. We say domain of the function is x belongs to real numbers, and then we say range of the function is y belongs to real numbers, where y is greater than minus 1, correct? Now we get this from the equation itself. If I write x as a very large negative value, then 2 to the power of x will be almost 0, right? So when this is almost 0, f of x will approach minus 1. So that is how you could explain it, right? This is 1. Now greater than, that means it means two things. Second, if x is very large positive value, then let us say infinitely large, in that case 2 to the power of x will be infinitely large, so y is greater than minus 1, and there is no bound on the upper side, right? So that is how we get the range. Now we can find the x and y intercepts. So we can say, what is f of 0 equals? So if I write this equation as 2 to the power of 0 minus 1, anything to the power of 0 is 1, so we get 1 minus 1, which is 0. So that means the point origin is on the graph of the function, right? So this point origin is on the graph of the function. That means x-intercept and also the y-intercept is at origin, right? So that is what it means. Now with this information, we can actually sketch the graph, and we know exponential functions are always increasing, right? They are always increasing. So these are good characteristics to begin with. Now to sketch the function, let's look into that part also. We should have few values so that the graph could be accurately sketched, right? So we can take some values to sketch. So what I'll do here is take up some values, calculate, and then we can use those values on the graph for getting good results. So we can write some x values and calculate the value for 2 to the power of x minus 1, right? So what we saw here is that if I take a value which is let us say a large negative value, right? Large negative value. In that case, we know 2 to the power of x will be very low. Let us say we have a value which is approaching negative infinity, right? Approaching negative infinity. In that case, 2 to the power of x approaches 0, so this value approaches minus 1, right? So that really means that the horizontal asymptote is x equals to minus 1. So we could draw a dotted line here showing the horizontal asymptote, right? Now we can take some values as x is equals to minus 1. So if I take minus 1 here, it becomes 2 to the power of minus 1, which is half, and half minus 1 will be minus half, right? So let me take a value as 0. Anything to the power of 0 is 1, so we have 0 minus 1 minus 1 will be 0. Then we can take 1, 2 to the power of 1 is 2, 2 minus 1 is 1, and then we can take 2, for example. 4 minus 1 is 3, and then we can take 3. 2 to the power 3 is 8, 8 minus 1 is 7, and likewise we can take more values, correct? So let us plot these values. At 0 we have 0, at -1 we have half as the value, okay. At 1 we are looking at 1, 2 the value is 3, so 1, 2, 3. At 3 it is 7, 3 it is 5, 6, 7, right? So that is how it is. At 4 it will be to the power of 4, 16 minus 1 is 15, so we can take this value 15. Now connecting these points will give us a good graph, right? So we are approaching on this side the horizontal asymptote, which is kind of 0, right? So that is half we go through, then that is the origin. It's a smooth graph which is increasing all the way, right? That is how we could actually connect these points, and the arrow at the end indicates the end behavior, that as x approaches infinity, infinitely large number, the y value also approaches infinity, right? So that is how we could sketch our graph. So here we have horizontal asymptote, which is y equals to -1, and this is our intercepts, both x and y, right? And as you can see, the function is always increasing, right? So that is how we get the graph of this function. From the graph you will also notice that the difference in y values is multiple of 2. For example, here delta 1 is and delta y is equals to 1. This difference between 0 and y value is 1, and then the change is equals to 2. That means 1 times 2, and at this stage the change is 2 times 2, 4. Do you see that? So what I'm trying to say here, that this change is of 1 unit, here the change is of 2 units, right? In this case the change is 1, 2, 3 and 4 units, right? And at the next level it should be 8, right? So it should be 8. So from here 1, 2, 3, 4, 5, 6, 7, 8. So here delta y is equals to 8. So there is a pattern, and that is times 2, right? So from the graph, what you notice here is the first difference has a pattern which is times 2, right? So we have a pattern which is times 2. So that actually reflects that the base is 2. I hope with this you get good understanding of exponential function from the equation and how we can actually sketch it. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.